A 99% of creatures could not survive this cold. But one giant thrived where others vanished. This is the story of the woolly mammoth's engineering. Its survival relied on specialized biological systems. First, let's examine the insulation system, its iconic fur. The outer guard hairs were nearly 1 meter long. But this structure trapped air, creating an unparalleled thermal barrier. Beneath this, a dense undercoat provided vital secondary protection. Thicker than any modern elephant's skin covering. But now that we understand insulation, let's explore locomotion. The massive feet needed specialized support for deep snow travel. And they evolved a thick, fatty pad beneath the sole. But this prevented sinking, acting like natural snowshoes for the giant. The neck held up the immense head, often weighed down by tusks. A robust vertebrae and powerful ligament systems were essential. But these allowed for sustained foraging in harsh conditions. This sustained them through long periods of resource scarcity. And now, we turn our attention to the incredible multi-purpose trunk. Unlike modern cousins, the mammoth had two finger-like projections. These allowed for incredible dexterity in harsh grip scenarios. The trunk contained over 150,000 muscle units, non-bony. It served as a powerful snorkel when crossing deep glacial waters. And acted as a high-pressure water delivery system for hydration. But this adaptation was key to accessing scarce resources. It could clear meters of packed snow to find forage. And now that we understand the trunk, the magnificent tusks await. With these were not merely weapons, but multifunctional survival tools. Tusks grew continuously, composed of layered dentin, or ivory. The tips often showed significant wear from constant scraping. They were the ultimate Ice Age shovels, digging through permafrost. In mating season, they served as impressive visual displays. Their curvature varied greatly, potentially signaling age or lineage. The sheer size communicated dominance across the frozen plains. The foundation for these tools lay in the skull structure. Crucially, the nasal passages were adapted for freezing air. But turbinates acted as heat exchangers, warming air before lungs. This minimized heat loss, critical for an animal this large. Its sheer mass also served as thermal inertia. Less surface area exposed meant less heat could escape the core. Noticeable by their small sizes, the ears were vestigial radiators. Unlike tropical cousins, radiators were a liability here. Survival required managing immense internal energy needs. But a thick layer of blubber provided emergency caloric reserves. But even the eyes needed protection from wind and ice crystals. A vascular constriction minimized blood flow to extremities. This combination built an ecosystem-specific biological machine. The trunk stripped bark for nutrients when grasses were scarce. But tusks could also pry frozen carcasses apart for bone marrow access. But the entire cranial structure was engineered to withstand these forces. But every feature served a primary purpose, surviving the deep freeze. The fur density provided unparalleled insulation efficiency. Its ability to regulate core temperature was unmatched. At their remains, preserved in permafrost, offer these crucial insights. But each ring tells a story of a harsh ice age here. But the trunk mastered manipulation, the coat mastered retention. The tusks were the excavators, the ultimate specialized plow. Its entire physiology was tuned to maximize heat retention. But this anatomical masterpiece dominated the Pleistocene world. Understanding this extinct giant teaches us about extreme adaptation. The engineering of the woolly mammoth remains nature's cold weather triumph.